Hello everyone. In this video we will learn about quadratic equations as well as quadratic expressions. So what is a quadratic expression? An expression of the form ax square plus bx plus c where a should not be equals to 0 is known as a quadratic expression. Here the condition is that the value of a should not be 0 because if a is 0 that means this whole term becomes 0 and we only will have bx plus c, and bx plus c is not a quadratic term, it will become a linear term. So for this term to remain as a quadratic term, the value of a should be not equals to 0. So any expression of the form ax square plus bx plus c is known as a quadratic expression where the value of a should be not equals to 0. And very similarly, quadratic equation can be defined. An equation of the form ax square plus bx plus c equals to 0, where a should not be equals to 0, is known as a quadratic equation. And this is an equation in terms of x. So x is representing a variable here. We can call x as either a variable or an unknown. So we call this is a quadratic equation in x or a quadratic equation in an unknown term x. A, B and C are constants in this equation. So in the term ax square plus bx plus c equals to 0, this is a quadratic equation. The first term ax square is called as the quadratic coefficient. A here in ax square, the whole term ax square is called as the quadratic term, whereas a here the coefficient of x square, something along with the variable, anything which comes along with the variable is called as the coefficient. So here a is coming along with x square, so a is the coefficient of x square and we call it as a quadratic coefficient. The second term here is bx. Here the power of x is 1, so we call it as a linear term. And b is coming along with x, so b is the coefficient of x. So we call b as the linear coefficient, whereas c is alone without any x involved with it. So we call c as either a constant term or we can also call it as a free term. So an equation of the form ax square plus bx plus c equals to 0, where a is not equals to 0 is known as a quadratic equation. Quadratic equation in a variable x. Here x is representing a variable and a, b, c are constants. We can call a as a quadratic coefficient because ax square, this whole term is a quadratic term because the power of x is 2. Whenever we have the power as 2, we call the term as a quadratic term. So a is the coefficient of x square, so we call it as a quadratic coefficient. The power of x here is 1, bx, the power of x is 1. So b is the coefficient of x power 1 is a linear term, so we call b as a linear coefficient, whereas c is independent of x, so we call c as either constant term or a free term. So let us consider an example of a quadratic equation, an equation in terms of x. So the equation here, the example is 2x square minus 3x plus 4 equals to 0. You have a very similar form. This is in the form of ax square. This is in the form of ax square plus bx plus c equals to 0. So this can be considered as a quadratic equation, a very simple example of a quadratic equation. 2x square minus 3x plus 4 equals to 0. So the name quadratic comes from the word quad, meaning square, because the variable gets squared here like x square. As I already told, when the power of x is 2, we call the term as a quadratic term, and it has come from a word quad which means square. Here x is getting squared, the power of x is 2, that means x is 2 times, so x is getting squared, so we call this as a quadratic term. It is also called as an equation of degree 2 because the highest degree of this equation, whatever is the highest power of x in the given polynomial, in the given expression, or in the given equation, that highest power is considered as the degree of that polynomial equation. So here this is the quadratic equation, the highest power of x here is 2. So we call this equation also as an equation of degree 2 because the power of x here is 2, because this 2 is uh, involved in terms of x square. So 2 is on x, so we call this as a quadratic equation or an equation of degree 2. Now let us see what are the roots, how many roots this quadratic equation will have. A real number alpha is called a root of the quadratic equation ax square plus bx plus c equals to 0 if a alpha square plus b alpha plus c is equals to 0. So any number alpha, any real number alpha is called as the root of the equation when we substitute that value in place of x and the whole terms becomes 0. On substituting this value alpha in place of x, if the equation completely becomes 0, then we say that alpha is the root of the quadratic equation, and alpha is also called as the solution of the equation ax square plus bx plus c equals to 0. Any value which when we substitute in place of x makes the whole term 0, that value is called as either a root of that equation or a solution of the equation. So what are the roots of this quadratic equation? A quadratic equation ax square plus bx plus c equals to 0, a not equals to 0 of course, has two roots or two solutions because the highest power of x here is 2. Because of the highest power of x, here the highest power of x is 2. So the equation x value will have two values here. The quadratic equation will have two roots because the highest power of x in the equation is 2. The quadratic equation will have two roots, that means x will have two values, two roots or two solutions a quadratic equation can have. So remember, a quadratic equation has two roots or two solutions. Whatever is the highest power of x in a particular equation, that many values x will have, that many roots that equation can have. So here the highest power of x is 2. So a quadratic equation can have two roots or two solutions. Now, what are those roots? The roots of the quadratic equation ax square plus bx plus c equals to 0. Of course, your condition you cannot forget, a not equals to 0 or x equals to minus b plus or minus under root b square minus 4ac whole divided by 2a. So as we have seen that a quadratic equation can have two roots. The two roots of the quadratic equation are minus b plus or minus root b square minus 4ac whole divided by 2a. Here we have plus or minus, so there are two values in this. One is we can say one is minus b plus root b square minus 4ac by 2a, and the other is minus b minus root b square minus 4ac by 2a. So these two are the values of x, the two roots of the quadratic equation. So together we can write these roots as minus b plus or minus under root of b square minus 4ac whole divided by 2a. So let us see now what are the roots of the quadratic equation. The roots of the quadratic equation ax square plus bx plus c equals to 0 are x equals to minus b plus or minus under root of b square minus 4ac whole divided by 2a. So a quadratic equation has two roots. The roots are minus b plus or minus root b square minus 4ac whole divided by 2a. So we can see how we are getting these roots, how we can find the roots of the quadratic equation. So let us consider the equation here. Consider the quadratic equation ax square plus bx plus c equals to 0. What we will do? We will divide this equation throughout. Divide throughout by a. So ax square by a, each term we are dividing by a, b by a into x plus c by a equals to 0 by a. So here a and a we can cancel, we get x square plus b by a into x plus c by a equals to 0 by a will be 0. Remember 0 by anything is equals to 0. Now in order to find the values of x, we try and make this a perfect square. So what we can do, we have x square here. This is in the form of a square. This is in the form of 2ab. We need to convert the second term in the form of 2ab. So 2 is missing here. So we will multiply as well as divide by 2. The second term where we have x, we are multiplying and dividing by 2. So multiply and divide by 2 only for the second term. That means the term where the power of x is 1. So only this term we are multiplying and dividing by 2. Now we can try and convert this in the form of a square plus 2ab. So this is a square plus this is 2 into x. If we see left out term is b by 2a plus c by a equals to 0. We have just multiplied and divided by 2, so that we need to make this in the form of 2ab. 2 was missing here, so we have multiplied 2 and we have divided by 2. Now we are splitting this in the form of 2ab. So we understand this is a square plus 2a. Whatever is remaining is b. So this is in place of b. In order to make it a perfect square, we need to add and subtract. We need to add and subtract b by 2a whole square. Okay, adding and subtracting b by 2a whole square. So this will be a square, this will be 2a into b. So let us add this b by 2a whole square. Let us subtract as well. So in mathematics, whatever we add, same thing we need to subtract. Same like whatever we multiply, we divide. So that after cancelling this step, we go back to the earlier step. Now if you see, this is in the form of a square, this is in the form of 2ab, and this is in the form of b square. So a square plus 2ab plus b square, we can write it as a perfect square, a plus b whole square. So same thing we can write with the first three terms of our equation here, a square plus 2ab plus b square form. So we can write this as a plus b whole square. Okay, what is remaining now? We have minus b by 2a whole square plus c by a equals to 0. So this 1, 2 and 3, these three put together, we have converted this in the form of a plus b whole square. So we can write x plus b by 2a whole square is equals to, we will take this minus term on the other side. This comes here and becomes plus, and this plus c by a comes on the other side and becomes minus. So that we can write x plus b by 2a whole square is equals to, when you square this term b square, numerator separately, denominator 2a square will become, 2a whole square will become 4a square minus c by a. So x plus b by 2a whole square is equals to, let us take the LCM on the right hand side. We have 4a square and 4a. The LCM of 4a square and 4a will be 4a square. So here we have 4a square. we need to multiply 1. 4a square into 1 is 4a square, 1 into numerator. A into 4a. If we multiply with 4a, we get 4a square. So 4a we need to multiply with numerator. 4a into c will be 4ac. So x plus b by 2a. This square we will take it on the other side. Remember, when we have square we should have two values. So that is why we are writing this plus or minus, and the square comes on the other side and becomes root. So plus or minus is simply because the power is 2 and we should have two values. So one will be plus, one will be minus, and the square comes on the other side becomes square root. So x plus b by 2a is equals to plus or minus. We can separately write root for numerator, whereas the denominator can be root 4 comes out and becomes 2. A square, root and square of a cancels, this becomes 2a. So x equals to, take this b by 2a on the other side, it comes here and becomes minus plus or minus root b square minus 4ac whole divided by 2a. So denominator is same, 2a and 2a. We can write the denominator commonly here. So we have minus b here plus or minus root b square minus 4ac here. So with this, we are able to prove that the values of x are minus b plus or minus under root b square minus 4ac whole divided by 2a. Nothing but the roots of the quadratic equation ax square plus bx plus c equals to 0 are minus b plus or minus root b square minus 4ac by 2a.